Hare Ram, Hare Krishna, Hare Ram. So ICSE students, welcome back to Shiksha Marg 108. Today we're going to be learning about an interesting topic of mathematics, section and midpoint formula. So let's jump right into it. So here we are on the screen. Now obviously this is the first topic, first question, but I'm going to be explaining to you the general idea about this topic. Now the idea is that you have normally a line segment given which is in the form of A and B. I'll read the question for you first. So it's saying calculate the coordinates of point P which divides the line segment joining. So we got the 2 points of the line segment which is A and B. So we'll write that down over here, A, B, and we note the coordinates as well. A is 1, 3, B is 5, 9. And this point P divides this line segment in the ratio 1:2. What does that mean? 1:2 means there are 3 parts. That's as plain as simple. So that's 1 plus 2, 3. So let's divide this line into 3 parts. Let's make the sense of it. It's going to be the first part, the second part. So now as you can see, 1, 2, 3 parts. Yeah, and we need to have a point P which is going to be over here, let's say, because there are 3 parts and this is 1:2. So this part is 1 and these two combined are going to be 2 parts. Does that make sense? Quite simple, yeah? So I'm going to remove this part. So you got actually 3 equal segments or sections of this line segment. And we got a point P which is dividing this line segment in a way that section 1 is just 1 part of that line segment and section 2 is 2 parts of the line segment. So I'll just remove this part as well. All right, this is making sense now. So this is 1:2. We'll have a general idea of this as M and N. You can have any variable. You can have M1 or M2. You can have A, B, but it's preferred, take something which is quite simple. So it's M or N, or you can have M1, M2. I prefer MN. That's pretty straightforward, but it's up to you. You can do M1, M2 or M or N as you please. Now the coordinate P would be X, Y, right? So P would have coordinates X and Y. The questions are going to be framed around these few aspects. So either they give us the line segment AB, which is what they've given over here with the coordinates as well. They've given us the ratio as well, which is M and N. And they're asking us to find the coordinates of the point which is dividing this line segment, right? So that's something which they're going to be asking, number 1, let's say. If let's say they've given us this, it could be something, let's say 2, 4 or any coordinate, it doesn't matter. Let's say they're given some coordinate. They're given the line segments points as well, A and B, and they're going to be asking us what is the ratio now. So that's going to be number 2. Does that make sense? So they're going to be asking us what is the ratio. Fine. I'm sorry, I should not have removed that bit. Yeah. Now, and the third bit would be they've given us the point which is dividing the line segment. They've given us the ratio. They've given us 1 point. They're asking us to find the coordinate of the other point. So that's something what they're going to be playing around with. So these are the different ways in which the questions are going to be asked. I hope that makes sense to you. All right. So let's jump to a question which is basically what they're asking us. And I'll just make this a bit small and take it over here. Or what, just let me make it small a bit. Yeah, there you have it. Fine. Okay, so the general formula would be, I'm going to write the general formula over here. This is going to be Px equals M times of just hang on for a moment, please. I need to put the coordinates over here for the general formula. So let's call this as x2, y2. Let's call the coordinates of A as x1, y1, and obviously P has coordinates x and y. So we are finding Px, which means we're finding P, x and y. So if I want to find the x coordinate only, I'm going to write Px. All right, P suffix or subscript x. So that's going to be Px equals. So the formula is going to be M times x2. So we focus on the x coordinate now, plus N times x1, and that's going to be the general formula now. That's the general formula throughout, the whole upon M plus N. And if I want to now find the value of Py, so I'm going to do that, the y coordinate that is. So it's going to be the same formula, but instead of the x, we're going to be, interchanging it with the y value. So that's going to be M times y2 plus N times y1, the whole upon M plus N. Yeah, pretty straightforward, yeah, isn't it? Now we're going to be putting the values over here. Let me use a different color ink. So that's going to be m is given as for us 1, x2 is given as 5 plus 2 times 1 the whole upon 1 plus 2, which is m plus n, 1 plus 2. That's going to be 5 plus 2, 7, the whole upon 3. So that's the first bit. We got x coordinate as 7 over 3, right? 7 over 3. And the second one is going to be, so m is 1 again, y2 is for us 9 plus n is 2 and y1 is 3, the whole upon 1 plus 2. That's going to be 9 plus 6, the whole upon 3. That's going to be 15, the whole upon 3. That's going to be equal to 5. So the y coordinate for this point now is 5. That's pretty straightforward, isn't it? So that's pxy is now 7 over 3 and 5. That's the whole idea about it. I hope this makes sense to you. Now we go to the second question. So again, quite straightforward. It's a very mechanical process now. Have the line segment in a slanting way that makes it a much, just takes less space probably. It feels good. Okay, a is minus 4, 6, b is 3 minus 5, and we need a point which is dividing this line segment the ratio 3:2. So that's basically 5 parts of this line segment. So this is going to be 1, 2, 3, 4, right? So that's going to be 1, 2, 3, 4, 5. Yeah, this is slightly bigger, but spare me for the inaccuracy. I'm doing it by hand. All right, so we're going to be putting the point as pxy. The ratio is 3:2. Of course, this is m, this is n, this is x2, y2, this is x1, y1. Now we need not always write this m is to n. We get the idea that is the formula. So next time I'm not going to be writing this. I'm just going to be getting into the actual value putting in the formula. So we need the value of x and y for coordinate p. So sorry, for point p. So it's going to be px, which is going to be equal to 3 times the x coordinate, which is 3. Again, 2 times the x coordinate, which is going to be minus 4, the whole upon 3 plus 2, which is 5. Yeah, that's going to be 9 minus 8. So that's 2 minus 4 is going to be minus 8. That's going to be 9 minus 8, the whole upon 5. So we got 1 over 5. So if you're finding the coordinates of point P, we got the first one, which is 1 over 5, which is the x coordinate of P. Yeah, and now we go and do the same thing for the y coordinate of P. Is going to be 3 times minus 5 plus 2 times 6, the whole upon, that's going to be 3 plus 2. So it's going to be minus 15 plus 12, the whole upon 5. It's going to be minus 15 plus 12 is going to be minus 3 over 5. That's pretty much it. So we can't really divide it further. So that's x coordinate 1 over 5, y coordinate minus 3 over 5. That's your answer. Pretty straightforward, yeah? Okay. We go to the next question now. So this is the next question. So we go to the next question. Now the question is, okay, I'm going to read the question first and then I'm going to solve it. In what ratio? So obviously now they're asking us m and n value. Is the line joining? So this is the point A, let's say for us, and this is the point B, and it is divided by the x-axis. All right, so quite interesting. So we got a line segment A and B, which we're going to do right now. So which is A 2 minus 3, B is 5, 6, and very interestingly, they're asking us to know how the x-axis is dividing this line segment. All right, quite straightforward. They're asking us how this x-axis divides this line segment. I'm going to just have it over here. It doesn't matter if it's over here. We don't know the ratio. That's how the x-axis. I'm going to write this down as x-axis, and this is dividing the line segment AB in the ratio m is to n. Okay, this is m is to n. Now let's call this as point P. Now there must be something interesting. They've given us x-axis. In mathematics, always go from the known to the unknown, always and every time. How does that work? That works by, if you have the x-axis, I'm just going to draw it over here, and I'm going to have a line over here. Okay, this is a random line, and let's for the moment draw the y-axis as well. Okay, just for a moment, let's draw the y-axis as well. So this is the origin, this coordinate, the coordinates of the point O's would be 0, 0. Let's say the line, which is this line segment, this random line, is intersecting the x-axis. Let's say this is x, this is y, at the point, let's say 2. What is the y coordinate? It's going to be 0. So it's always known that whenever the x-axis, when we're finding a point on the x-axis, the y coordinate is always going to be 0. And let's for a moment talk about the y-axis as well. So I extend this line over here, and this is where this point is intersecting the y-axis. So obviously this is going to be the negative side of things. Let's say this is minus 3. Minus 1, minus 2, minus 3. This was, let's say, 1 and 2, right? This is minus 3. So the x coordinate is always going to be 0 and y coordinate is going to be minus 3. So we're going to be having the y coordinate till, it can go to positive infinity or it can go to negative infinity, but this always remains constant. This always remains constant. Same for the x-axis as well. The x coordinate can take value from negative infinity all the way to positive infinity, but the y coordinate on the x-axis is going to be remaining same. It's going to be 0 always. So that is what they've given us. This is basically the understanding of it. So when we have this point P, this point P is on the x-axis and it's intersecting this line AB as well. So we know 100% for sure that x coordinate is going to be any value on the x-axis. We have no clue what that would be. They didn't ask us that. But the y coordinate is always going to be 0. This is for sure. So we always go from the known to the unknown. Does that make sense? Fine. So now how we do, since we now got the idea about the coordinate P, now we can jump on and find the values of M and N. How do we do that? We take the value of the known coordinate of point P, so that's going to be Py is known. Py is going to be M times 6 plus N times minus 3. So we're taking the y coordinates of the point A, B, and now. So N times minus 3, the whole upon M plus N. But hey, hang on. We know what is the y coordinate of P. It's going to be 0. So we say it's equals to 0. That's where we get the answer now. So we solve for the numerator now, and the M plus N part will go on the other side. It will become 0, because 0 times anything is going to be 0. So 0 times M plus N equals 0. So this is going to be 6M minus 3N equals 0. And there you have it. That's going to be 6M equals 3N. So M over N equals 3 over 6. So this 6 goes on the other side. 3 over 6 is going to be 1 over 2. That's half. So M is to N, which is going to be the ratio 1 is to 2. So that's basically how it's dividing the line segment AB, 1 is to 2. Pretty straightforward. Quite an interesting sum, I would say. I hope you got the idea. Stay tuned for more. I'm going to be getting all the exercise sums done just for you, so that you get a complete idea of how to solve these sums, right? I hope this is making sense. Please carry on with your exercise preparation. Look at the assignments which are given in Shiksha Marg 108.com website. I hope this is making all sense to you. If there's any difficulty, you can put it in the comment section. I would really like you to like our channel, share as much as you can with your friends, and obviously subscribe so that you get the latest videos of all the topics that we're covering in this series. All right, well done. So keep on practicing. If you have any doubts in the comment section, please put all the things. We would look at it and we would be very happy to see what can be done for you guys. All right, so all the best. Do well. Hare Ram, Hare Krishna, Hare Krishna, Hare Ram.